Okay, we're going to talk real quick about experimental design. I know you've had this in the past, so I'm not going to spend too long on it. You need to figure out what you are going to change and test. That's going to be your independent variable, what you change and test, and then you're going to measure something. You're going to measure something that gives you data that helps you evaluate what you changed. And then finally, you're going to try to have a control trial. Not all experiments will have a control, most of them do. And then you're going to have a lot of constant or controlled variables, things that stay the same throughout the entire experiment, so you know the results are just because of the one thing you changed, not because of all these other things, because you kept them all the same. So independent variable, you can remember that it's what I change, what the independent person changes or tests. Just think I. I change, I test. Dependent variable starts with a D. Just remember it gives you the data that answers your question. You may have a lab where you measure a ton of different things, but the one thing that you measure in the end that gives you the data that answers your question is your dependent variable. So let's look at a scenario real quick. You wanted to see how the color of a car affects the temperature it will reach inside. You may know something about this. You may know that the darker color cars tend to heat up a little quicker and tend to be warmer than the lighter colors. So what you're going to be testing, what I change, I test, what I'm going to manipulate here is the different color cars. So I'm going to look at red, I'm going to look at blue. I might choose not to look at green color cars, or I might choose to include green. It's up to me. That's my independent variable, the color. And then dependent is the data that gives me the answer to the problem. I might measure how long they've been in the sun. I might measure the temperature outside. I might measure the temperature that the cars were before they were put into the sun. But what is most important is the data that answers the question, which in this case might be final temperature or overall temperature change inside the car. Ski wax example. A ski racer wants to know which of 3 waxes he should put on his skis for the next big race. The independent variable in his little experiment, because he's going to try out 3 different types, would be the wax type. He chooses to test 3 different types of waxes. And then how do you know which is better? What specifically is he going to measure? Well, he's probably going to measure something like speed or the time it takes for him to get down the mountain. And then the wax that leads to a faster time is better. I'm using better in quotes here. You really want to be able to define what you mean by better. Is better because it's easier to put on? Is better because it's cheaper? Is better because it helps him get down the mountain faster? And so forth. So try to avoid words like that unless you clarify what you mean by better. And in this case, it's time to get down the mountain, which is measurable. Sugar tests. Imagine that a school district wants to know if the consumption of sugar prior to testing has any effect on CAP scores. Now, we've been trying this for the past couple of years, giving kids little treats and stuff before the CAP test. Is sugar a good idea? So maybe we want to test sugar, and we want to look at the different amounts of sugar. So that would be my IV. I want to see if a little bit of sugar helps, if a lot of sugar helps, if a ridiculous amount of sugar helps. And then how do I know if that's good or not? Well, I have to measure something. So maybe I can measure the test scores earned by the students consuming different amounts of sugar. All right, control versus constant variables. The control trial is something different than constant or controlled variables. Okay? There are only 2 variables that change. There's only 2 things that should change in an experiment. Everything else has to stay the same. Here are the 2 things that change. The independent variable is the one thing that you will change. The experimental will decide to change this, and then they want to see how the data is affected by that. So they're going to measure some stuff, and then they're going to look back at the independent variable and be able to make some determinations about whether or not it had an impact on the data. So these are the 2 things that should change. For instance, you want to vary the amount of time you study for tests over the course of the year. Your grade, which is measurable, that's your dependent variable, is a reflection of or is dependent upon the amount of time you studied. That's the independent variable. So you can control the amounts of time that you study, and then your dependent variable is going to help you measure and decide, does it really matter if you study for 1 hour or not at all, or 15 hours for a test. Now the constant variables, sometimes they're referred to as controlled variables. These are things that are held constant, which means they're kept exactly the same. Only the independent and dependent variable should change, nothing else. This is not the same as a control. Constant variables or controlled variables are not the same thing as a controlled trial. A controlled trial is a trial in which we want to collect baseline data. We want to see what happens if we don't do anything to our experiment. We don't change anything, and let's see what we get for data. And then we're going to change stuff and compare all the data to that and see if it really made a difference. Not all experiments have a control. What if you don't study at all? That might be your control trial. Don't study, see what you get as a score, and then you can go ahead and vary the amount of time you study and see how the grades differ. Okay, so not studying at all is your control trial. But controlled variables, things that we have to keep the same, might be when you do study, you always study up in a quiet place. You don't study in front of the TV. You study the same way. You always use flashcards, or you never use flashcards, or you always rewrite your notes, or something like that. Or you always study at the same time each night. You don't want to study at 5 in the morning one day and then you study at 11 o'clock at night another day. Maybe the results that you're getting on the test is because you're more alert when you're studying at one time versus the other, as opposed to studying for more or less time. So all those other things that you want to keep the same are your controlled or constant variables. The control trial is just a trial you do nothing to and see what you get. Now let's take a look at the sick baby scenario. And I put a little phrase under here. How do I know if the medicine's working? Now let's imagine a little baby is sick. Both the mom and the doctor worry that the little baby is getting dehydrated and losing weight. It's a major concern for newborns. The doctor puts a baby on a new medicine with the hope that the baby will respond and not lose any more weight. Now the doctor wouldn't be able to tell if the medicine was working unless he had some baseline data to compare the new data to. So obviously a good doctor would weigh the baby first, then put him or her on the medicine, and then measure the weight again. And you want to see what the new weight is compared to the controlled data, compared to the original trial where you do nothing to it. Don't put the baby on the medicine yet, see what the weight is, and then you're going to vary something. And that's the only thing you want to vary. You don't want to give the baby a different type of formula or milk. You don't want to keep the baby in a different environment. You want to keep everything else the same. You just want to change the medicine. And then you can know truly if the medicine's working or not. Getting back to that ski racer, he's going to test 3 different types of waxes, so he runs 3 different trials, 1 with each wax, or maybe 5 trials with each wax, and then he can average the variable or the numbers. He's going to measure how fast it takes him to get down the mountain. That's his dependent variable. Those are the only 2 things he's going to vary. He's going to have a controlled trial, which is a trial with no wax at all. He's going to see how long does it take him to get down the mountain with no wax, and then he's going to try the different waxes and make a comparison. And then finally, he's got to keep everything else the same. He's got to have all these other constant variables. So he might ski the same run on the mountain. He might ski it at the same time of the day, in the same weather conditions. He might use the same exact skis. He might run the test so it's the same skier. If he did it with wax A and his friend did it with wax B and his friend got down first, it might be because his friend's a better skier, not because wax B is better than wax A. So those are constant or controlled variables, things that you have to work hard to keep the same in the experiment, so you know the results are just due, in this case, to the different types of waxes, not to all these other things that you didn't keep the same. And lastly, the sugar test on the CAP scores, or on the CAP test, the district, the school, could change the amount of sugar that the kids get before the test. That's what they're going to change. They're going to see if that makes a difference by measuring something. They're going to measure the test scores. Now they're probably going to have a control group, which is a group where they don't give any sugar to. And then finally they're going to have a bunch of things that they keep the same. They're going to have a lot of controlled or constant variables. So they're going to purposely make sure that the kids are all the same ability to start with. The kids have all been prepared in the same way. The kids are all taking the same exact test. The kids are all taking the test at the same exact time of the day, and so forth. If any one of those variables changes, then you don't know why you got the results you got. Do you get the results because the amount of sugar changes and that causes better scores? Or do you get the results that you get because you change something like giving one group a harder test than another, or giving one group better preparation than another? So everything else has to be the same, but the one thing that you're going to change, which in this case would be the amount of sugar, and then you're just going to measure the dependent variable, which in this case is the test scores, and see how the independent variable affects the dependent variable.